The champion in terms of its mass is the black hole in the center of a quasar known as 10618. This object was stumbled upon in 1957 when white dwarfs were being explored and initially caused a lot of puzzlement on the part of the scientists. The notion of quasars was to appear only 6 years later. That is why the nature of the object was rather vague. On photographic plates taken with a 0.7 meter Schmidt telescope, it was listed as number 618 and described as decidedly violet. It was only in 1970 that radio emission from TUN 618 was discovered at the Institute for Radio Astronomy of Bologna. This emission was indicative of the fact that it was a quasar, and moreover, the most luminous quasar known to science at the time. It is assumed that there's an accretion disk of hot gas in TUN 618 surrounding a gargantuan black hole in the center of the galaxy. The gas must move around the disk at a tremendous speed, reaching 7,000 kilometers per second. This object is located in the constellation of hunting dogs, or Canis Venatici, and is 10.37 billion light-years away from us. The galaxy containing TUN 618 cannot be seen from the Earth due to the luminosity of the quasar itself, which is 140 trillion times as intense as that of the Sun. The contemporary view on quasars defines them as active nuclei of galaxies at the first stage of their formation. The nuclei's supermassive black hole sucks in the surrounding matter, thus forming an accretion disk. This disk is the source of luminosity of enormous power that is sometimes more intense than the aggregate luminosity of all stars and galaxies like ours. The brightest quasar, which was discovered in January 2019, has the luminosity of about 600 trillion suns and is 12.8 billion light-years away from the Earth. What could be the mass of an object finding itself in the center of a light cannon like this? According to today's estimates, the mass of the black hole in the center of the TUN 618 quasar reaches 66 billion times the Sun's mass, which makes it the heaviest black hole in our galaxy known to science. Black holes of this mass are categorized in a different group and are referred to as ultramassive black holes. In fact, the TUN 618 quasar isn't the only object in this category. Within the constellation of Cancer, for example, which is 3.5 billion light-years away from us, the OJ287 quasar is to be found. It has a black hole in the center and is 18 billion suns masses. In the center of the Phoenix cluster, there's a rapidly expanding black hole, which at this moment is 20 billion times the Sun's mass, building up 60 Sun's masses a year. One of the best-known black hole giants is located in the galaxy NGC 1277 within the Perseus constellation. The object reaches 21 billion Sun's masses, and its event horizon diameter equals 130 billion kilometers, which is 15 times the distance from Neptune to the Sun. However, at the moment, this giant practically isn't being active. Speaking about size, the undisputed holder of the first place on the list is admittedly another well-known space object, namely the black hole in the center of Holmberg 15A, a supermassive elliptical galaxy located in the constellation Cetus, or the Whale, 700 million light-years away from the Earth. This black hole isn't a champion in terms of its mass, which is 40 billion times the Sun's mass. Its dimensions, however, can't but amaze. According to today's estimates, the event horizon of this black hole could be as big as to accommodate our Sun and all of its planets. Its diameter is approximately 790 astronomical units. The Holmberg 15A galaxy must have been formed as a result of the collision of two smaller galaxies at some point in the distant past. A similar process is likely to be expected in our system as well, when the Milky Way collides with the Andromeda galaxy in 4 billion years' time. For now, astronomers plan to continue studying the phenomenon of the black hole in Holmberg 15A by carrying out complex and detailed modeling. Scientists are going to collate the results of theoretical calculations with practical observations in the future in order to try to establish how exactly it was possible for a tremendous black hole to come into being inside the two galaxies on their collision. In comparison to the objects mentioned above, our own planet may seem of no significance at all on the overall space map. But it should be noted that the age of practically all the supermassive objects in the universe is several times that of our Earth. For millions of years, these black holes have been gaining in their masses and expanding as the time went by. Today, we can observe their activeness as the result of the development of the entire universe. It is quite feasible that most of the ultramassive black holes were formed as a result of smaller holes merging. A similar process takes place when they collide, which is accompanied by the emission of gravitational waves. These occurrences must be the biggest contributors to the generating gravitational waves in the universe and are exceptionally attractive to scholars of gravitational wave astronomy. By now, several similar signals which came about as a result of two small black holes merging have been registered by the American observatory LIGO. Perhaps we will find out the names of other champions in the list of space giants in the near future. And now, all we have left to do is just await new, amazing discoveries. We live on a planet that is considered young in comparison to other planetary objects. Humanity is just 2.8 million years old, while the Earth is 4.5 billion years old. Long before our planet appeared, thousands of such habitable worlds were already in existence, and these objects are still somewhere in the nearest galaxies. Imagine if mankind had appeared a billion years earlier. What technologies would we have had at our disposal today? Based on calculations by a number of today's astrophysicists, it is an undeniable fact that there exist a great number of similar planets in the space. The presence of an advanced extraterrestrial life on such planets is simply a natural consequence. Why is it then that we still haven't received a single sign that would indicate the presence of anyone else around us in the space? What could be the reasons for this absolute silence of the universe? To try to answer this question, I will tell you about one of the most atypical and fascinating puzzles of modern cosmology, the Fermi paradox. Enrico Fermi is a scientist of Italian descent who emigrated to the United States shortly before the outbreak of World War II. Fermi worked on the design of the first nuclear reactor, but he became well known for a phrase he happened to drop in the cafeteria of the Los Alamos laboratory. During an informal conversation in 1950, Fermi, together with three other colleagues, were discussing a cartoon published in the New Yorker magazine. There was a picture of aliens unloading trash cans from flying saucers landed on their planet. The cartoon was associated with real disappearance of trash cans in New York, and aliens got into the picture because of the growing interest in extraterrestrial civilizations in those years. When discussing this cartoon, the scientists grew to be more serious, and then Fermi uttered a phrase that was to lie in the basis of an entire paradox. Have you ever wondered where they are? According to the scientists' idea, if extraterrestrial civilizations could really exist, we would have had at least three types of evidence: the presence of alien probes, ships, or radio emissions. However, despite all the ongoing research, none of these has been discovered so far. But Fermi was by far not the only scientist who thought about this. This question was raised much earlier by the Russian philosopher and inventor Konstantin Tsiolkovsky. And in 1975, astrophysicist Michael Hart described in detail the reasons of this paradox. Fermi's question was a sensible one to ask. Just imagine, any one of us can look at the night sky right now and see thousands of small stars. According to scientists, there are about 100 billion of them in the Milky Way alone, 20% of which have their own planetary system. Furthermore, in each of these systems there should be at least one planet similar to the Earth, and 10% of these planets that can potentially support life may well have an intelligent civilization. How is it possible that with such a high probability of the existence of extraterrestrial life, to solve this riddle, the American astronomer Frank Drake developed a simple mathematical formula in 1961. It calculated the probability of existence of intelligent races in the universe. Here is this formula. N. This is the number of civilizations which use communication methods that we could detect. I is the average annual rate of emergence of stellar systems in our galaxy. F sub p is stars that have planets. N sub e is the number of planets or satellites that can potentially support life. F sub l is the number of inhabited planets that develop life. F sub I is the probability of the emergence of intelligent life on inhabited planets. F sub c is the fraction of civilizations with detectable forms of communication. L is the time length of a detectable signal. Many astrophysicists have tried to calculate each of the presented values, but to this day, the Drake equation has no final solution. Given the absence of any signals from nearby stellar systems, it can be assumed that any civilization that grows to be technologically advanced runs a great risk of inevitable self-destruction. For example, due to a nuclear war or ecological collapse. Thus, any developed race has very little time to be noticed. However, if this does not happen, any civilization will sooner or later reach a level of advancement that is thousands of times higher than ours. In 1964, Soviet astrophysicist Nikolai Kardashev developed and published the method of technological advancement of civilization called the Kardashev scale. Using this method, the scientists suggested an idea about the capabilities of such developed races. These capabilities would depend on the amount of useful energy they could make use of. According to Kardashev, the first type includes civilizations that are able to use all the energy available on their planet. More developed races can use all the energy emitted by the main star. And the third type of race is able to use the energy of the... According to astronomer Carl Sagan, so far our level is 70% that of civilizations of the first type, and we will be able to reach their level completely in 1 or 2 centuries. But even earlier organisms that appeared in the universe comparatively recently could well have reached the level of advancement of the third type of civilization. With this kind of technologies, any races will be able to move through the space at a speed close to the speed of light, or even faster. If this really happened, we would hardly miss signs of their presence. However, the universe has never given us a single sign of this. It is likely that the reason for this is that we use only radio observation methods to search for other civilizations in the galaxy. In the entire history of the research on extraterrestrial civilizations, not a single star has been discovered that would demonstrate unusually intense radio waves. This leads us to the conclusion that we're the only civilization in our part of the galaxy that uses radio waves for communication. Perhaps if other civilizations do exist, we don't notice them because they use completely different types of communication. The universe is full of things we're unaware of, and if someone does live thousands of light years away from us, they might be able to use channels of communication unknown to us, for example neutrinos. Unfortunately, this version of the solution of the Fermi paradox is not the only one. Many scientists believe that our solitariness in the space is an inevitable fact. Maybe we simply don't know why other civilizations have died out. Others suggest that we simply have not yet reached the level of development sufficient for communicating with the universe, so it keeps silent. Others, proponents of the so-called zoo theory, believe that our level of development is too low compared to extraterrestrial races. Our radio signals disappear into the distant depths of the outer space without a trace. And who knows, maybe those who see them simply don't understand what they mean. Or maybe intelligent aliens are aware of our attempts, but will respond only in the fullness of time. While traveling around the universe, we have taken a look at only a few phenomena and space objects. Had we continued our journey, we would quite literally never have seen the end of it. The variety of as yet unexplored celestial objects and phenomena defies human understanding, and the lifetime of every human on Earth would not be enough to even talk about them all. But this is anything but a reason to give up on our search. And the process of studying and exploring the universe will continue as long as the human race exists in its tiny, habitable portion.